Hi there. Let's look at Friedel Crafts alkylation. The first picture is showing typically how you have seen in your books and your prof drawing that way. But the lower one, that's how I write it. And see the benzene shown the hydrogen to be replaced, substituted, and the catalyst goes on the arrow. Now you flip the alkyl halide and you can remove this HCl with the help of catalyst. And byproduct HCl removal is very important to understand this reaction. Because if you memorize the HCl, you know what is left to put together, right? So the R is left there, and then you have the benzene ring without a bond, so they're going to link, right? So that's how we draw it completely, the participation of the catalyst and the byproduct. Now also notice, due to the electronegativity of chlorine, the halide, the R is the electrophile, and the double bond on the pi bond on the nucleus is the nucleophile. So you substituted the aromatic ring's hydrogen. So the substitution took place. So therefore, this is why it's electrophilic aromatic substitution. Got it? So this is the one should be going to a cheat sheet before the exam, and reviewing should be done with this drawing. So color coded, every word meaning arrow is there. Now, if you want to know a little bit more about how the catalyst actually behaves, the cat is drawn this way in red, aluminum trichloride, and the alkyl halide, delta plus, delta minus, important. Now, the aluminum electron deficiency pulls out a pair of electrons, and then the R to the Cl bond breaks. Now you generate R plus the carbocation. So it would be CH3 plus, it could be C2H5 plus, whatever it is, right? Now the Cl is actually attached to the aluminum tetrachloro complex, the negative ion, the complex is sitting there. It has a purpose later. We're going to use that one. So this drawing, you can draw this way pictorially, so you can actually see how the bonds are, or you can simplify this way: CH3Cl, aluminum trichloride, draw a little box, kick out the Cl, you get the CH3 plus, the R plus, and Cl is sitting with the AlCl3 anion, right? Now you have that catalyst part is done. These are could be the arrow push, the questions based on that. Now also make sure in the benzene ring, mark this pi bond and the replaceable hydrogen. Any hydrogen is the same because it's symmetric, right? Now we can bring the alkyl plus, right, the carbocation. Now this one is sitting with the counter ion, aluminum tetrachloro negative ion. First arrow to the catalyst, second arrow the pi bond attaching to the carbocation, the R plus. Now we've done it. Now what we have, we didn't touch these two bonds, and the hydrogen we didn't touch it, but this one make a new bond with the R group, you see, with the R group actually, right? Now it is attached, but we have a new positive here, and also we have aluminum Cl4 negative, and this positive is more important. That will make the sigma complex. We call the sigma complex, we call them resonance structures, or it is stabilized by resonance structures, right? Now this negative ion act as a base and abstract the hydrogen to neutralize that positive. So now you recreate from the sigma complex the benzene again. Now the CH3 is attached, it's a substitution now because hydrogen is gone, CH3 is in place of that. Now the Cl, well actually this is dissociates the complex into HCl, so you regenerate the catalyst. Now also you want to pay attention as the third part of this discussion, the resonance structure stability. How does it work for the sigma complex? So you draw the first resonance structure as we did, and then you double arrow, and then you move this pair of electrons to make a new pi bond, and then the plus goes here. Now same way you move this pair of electrons to the new plus, and then you make a new bond, and the plus move to the next position, right? So this one you want to draw in order, this one nicely, and square bracket should be there, and the basic nature, the negative nature, will abstract the proton, and voila, you get the product, right? So stop the video and see 3 steps: the catalyst, the mechanism, and the resonance structure stability. The details how to draw the resonance structure. The 4th one, this one is for multiple choice questions. Now what you want to know, memorize it. R is an alkyl only. That means methyl, propyl, ethyl, butyl, something like that. Now, catalyst is aluminum chloride. It's a Lewis acid, zirconium tetrachloride, titanium tetrachloride, and so on. The Lewis acids are good. Even FeCl3 should work, right? The other situation here is the double bonds of X or triple bond X would not work, because that's the vinyl bond. Vinyl bond cannot be broken. That's what you have it in the PVC. Thank you.